Cabin pressurization. So this is the next one. So just two more quick topics, and then we should be wrapping up pretty quick here. A lot of your jets out there have the ability to pressurize the cabin to some degree. On your commercial pilot check ride, the examiner will most likely ask you about high altitude flying. Therefore, knowing about supplemental oxygen as well as cabin pressurization systems is required. There are no knowledge test questions on these pressurization systems, but we are preparing you for your future check ride here. So first thing that we need is a source of compressed air, something that will pressurize the air. And in this case, it is going to be the compressor in the turbocharger if you're using a turbocharged airplane. If you're using a jet engine, then there's a compressor that we will bleed the air off of that into the cabin. You may have heard the term bleed air. Well, it comes off the compressor section of a turbine. Okay. So that's our source. And see that source is right here. That's bad color. Right there's your source right there. So we're bleeding a little bit from the compressed air from the turbocharger into our cabin. Now this cabin here has a unique shape and design to it. Therefore, its technical name is called the pressure vessel. And the best way to think about it is a bottle. That bottle is the round shape. Your aircraft fuselage is a round shape. Round holds pressure equally on all sides. When you look at aircraft and you want to know is it pressurized or not, you look at the windows. Square windows, it's not pressurized. Rounded windows means it's pressurized, even oval. Yes,
windows on the front of the airplane square?
They'll have a rounded shape to them as well, right? As opposed to some aircraft that are a lot more square up front. All right, so we've compressed the air and we pumped it into the pressure vessel. The pressure vessel has the cockpit, it has the cabin, maybe baggage, maybe not, but we have to be able to regulate that pressure. Because pretty much we got pressurized air always coming in. You know, at takeoff, we're producing, in the climb, we're producing a lot of pressurized air coming into the cabin, right? In cruise, we throttle back and we still got quite a bit of pressurized air coming in. But usually on these more advanced aircraft, your descent is at flight idle speed. So you only have a little bit of pressurized air coming in. So you really got to be able to regulate that with valves. And the first valve you have to know about is called the outflow valve. Okay? And that's this blue one over here. Your outflow valve then is set to regulate that cabin pressure to maintain it at a certain cabin pressure altitude. Most typical on your jets, it's 8,000 feet, but that can be set higher or lower, depending on the aircraft and the operation you're in. But a lot of your commercial airline flights are somewhere around 8,000 feet cabin pressure altitude. The other one is called a safety or dump valve. That's the red one up here. Because it would be a really bad day if your outflow valve got stuck closed and then your airplane went boom and blew apart, right? That would be bad. So they have a backup valve to it called the safety valve. So if anything happens to outflow valve, the safety valve takes over and regulates the pressure. It also works as a dump valve. So upon landing of the aircraft, any excess pressure in the cabin is dumped overboard. Most of the time, when the main wheel struts contract, that is activating the dump valve. If you're paying attention, you might hear the air escaping, or you might feel a pressure difference in your ears if there was one. Okay. That's a very typical spot to do it. Because imagine if you have a pressurized cabin, you can try to open the outside cabin door. You're either not going to be able to because pressure's holding it closed, or if it's hinged the other way, it'll just blow open when you open it from the pressure pushing it out. That would be a bad day. There are some pressurization emergencies. Right? The first one is known as an explosive decompression. And this was the Aloha Air flight in Hawaii back in the early 80s. Right? Very explosively, a huge section of the fuselage, forward fuselage, ripped off the airplane. This was due to corrosion and pressurization cycles that weakened the metal further enough to have it just rip away. Okay. So, the passengers got a much better view of the surrounding Hawaiian Islands as they were flying in there. And a little bit windier too, I imagine. So explosive decompression is where it's pretty much an instant decompression, and it's faster than what your lungs can deflate from natural breathing. So the effect is your air is sucked out of your lungs. So if you've ever been kicked in the gut or in your diaphragm area and you've been winded, where your diaphragm just contracts the wrong way and forces the air out of your lungs, that's what it's like, or could be like that. Right? And often the cabin will fog up because of the quick change in pressure. Any moisture is condensated back into a cloud. So that's a bad thing when you have an explosive decompression. The other one is rapid decompression. It's a slower one. Typically, with the cabins decompressing in 10 seconds, you're able to breathe through that decompression cycle. So there's not really any damage possible to your lungs on that.